Here's a problem. The drill bit of a variable speed electric drill has a constant angular acceleration. That angular acceleration is 2.5 radians per second per second. The initial angular speed of the bit is 5 radians per second. After 4 seconds, what is the bit's angular speed and what angle has it gone through? See if you can solve this problem. I'll put up the equations up here. Okay, let's solve this together. I know that the angular acceleration is 2.5 radians per second every second. I know that the initial angular speed is 5 radians per second. And I know that we're looking at this thing for 4 seconds. In part A, we're looking for the final omega, and that makes this delta theta the who cares. Now, that means that I need the equation that doesn't have delta theta. I don't know delta theta, I don't want to know delta theta. I need to use the equation that doesn't have delta theta. Well, there's delta theta, there's delta theta, there's delta theta. I have to use this equation up here. So let's do that. So I say omega final is equal to omega initial plus how much the change I have per second times the number of seconds. So this is going to be 5 radians per second plus a change of 2.5 radians per second for each second times 4 seconds. That's going to be 5 radians per second plus another 10 radians per second during those 4 seconds, or 15 radians per second. Now, if I'm looking for the angle, I'm looking for delta theta. I plug in 15 radians per second, and now this goes from who cares to being worth $400,000. But because I have 4 pieces of information instead of 3, I can use more than one equation. Indeed, because I have all the other variables except for delta theta, I can use any of these equations that has delta theta in it. So I could use this equation to get my answer, this equation to get my answer, or this equation to get my answer. You might try using all 3 equations and make sure that you get the same answer in every case. You will, okay? Let's use this one here. Whenever I can, I try to use the top 2 equations because they're the ones that are actually the rewrites of the operational definitions of acceleration and average velocity. Okay, so let's use that second equation. I'm looking for the angle that this bit has moved through. That's going to be delta theta is equal to 1/2 omega initial plus omega final delta t. That's going to be 1/2. The initial was 5 radians per second. The final is 15. And the time is 4 seconds. 5 and 15 is 20. Half of that is 10. 10 times 4 is 40 radians. So it goes around about 6.5 times, a little more. Check that your neighbor's on the bus, people.